if the conservative side, the very safe side, which I think as scientists we often are, but if that side wins, we don't discover this. We don't make this breakthrough.
Hi, I'm Alan Levinson.
And I'm Zoe Latham. We're PhD students studying bioengineering here at UCLA.
Welcome to Behind the Beaker, where we uncover the inspiring stories, triumphs, and lessons of leading researchers, while igniting your passion for innovation in science and engineering.
Each episode highlights a researcher's personal journeys, breakthroughs, and setbacks while offering insight into the world of a scientist through their real-life experiences.
We hope to inspire and motivate you to pursue your own path in science, while learning about the challenges and rewards of a research-driven career.
Let's get into it. Hi, welcome to our second episode of Behind the Beaker. My name is Zoe, and we're interviewing UCLA's Professor Tyler Clites. And he's an innovator in rehabilitation and augmentation technology. He works with surgeons and innovators to improve bionic technology. So, Tyler, thank you so much for coming in today.
Yeah, thanks for having me. It's a pleasure to be here.
Nice. So, Tyler, I know that your work sounds very interesting to the abstract. What do you tell people when you meet them on the street? What do you tell them that you research?
Yeah, I think from a high level, you captured it well. We do technologies for rehabilitation and augmentation of human ability. I often frame that as highly invasive bionics. One of the things that sets our work apart, I think, from the rest of the field and folks who are doing bionics type research, bionics prosthetics, that type of thing, is that we think about the body as part of the engineerable system. In other words, we use surgery to engineer the body and the machine in parallel, so the two are better suited to interact with each other. So again, the kind of very quick framing for people on the street is that we do highly invasive bionic technologies.
And you're dealing with human lives, so failure is it's really important. But I know you have core values surrounding your research and mitigating pain. Can you tell me a little bit about those values?
There's a lot of attention and focus, I think, in certain research spaces on what the goal of the research actually is. I think in some worlds that's clean and clear and easy and obvious. I don't think there's anyone who's going to feel that curing cancer is not a good thing to do.
Everybody wants to cure it.
That's right. So if your goal is cure cancer, that's pretty clean. You're in a pretty good place. I think for us, we deal with more complexity. Disability is a complex thing. And I think the key is that everybody interacts with it differently. I have worked with many disabled people in my time as working in this space. And the thing I have come to learn most profoundly is that all of them are different. All of them are experience that disability differently. They're very real people who have very real emotions and very real connection to their disability, and that looks different for each of them. And so what I have, as I've kind of come up through this space, and being that I do not have a disability, I'm not disabled, so I am on the outside looking in that sense. What I've tried my best to do is to listen to as many of those people as I possibly can, and allow that to influence how I think about how I think about solving the problems that we're solving. What I have come to is that there are two, what I think of as fairly unassailable motivations for the work that we do, in that they are motivations that make life better in whatever way the people who are kind of living this want to take advantage of or not take advantage of, want to engage with or not engage with. So those kind of two priorities that I have, the first and the one that I think is probably the cleanest, is alleviating pain. Pain comes in a lot of different forms, and some of it is I think harder to nail down, put a finger on. But I think across the board, if we can reduce physical pain at a very least, and if we can start to take away emotional pain if it's there, I think those are really good things to be doing. And in the space I work in, this is actually motivating a lot of the work that we're doing right now, is we end up targeting parts of these problems of things that limit mobility, that interfere with kind of your ability to move, to locomote. We've been targeting ones that are associated with very high levels of pain, because I think, again, that's a clear and positive goal.
So tell me a little bit about how you do that work and what you do.
So the work that we do is very collaborative. We work very closely with surgeons, because we do things that are surgically invasive. We need that expertise in the room. I think another thing that sets our work apart is that, when we think about a system being designable, engineerable, what that usually means is that we're prototyping with that system. And in the case of the body, the materials that we use to prototype aren't metal and plastic and polymer, etc. But they're skin and bone and muscle, right? And so to do that, we typically build our design process around cadaver work. So we actually do dissections of human cadavers, people who have passed on and have graciously donated their bodies to science. We use those tissues, often full-on limbs, arms, legs, as a blank slate, if you will, from which to engineer. So we come together in a room with my team, the engineering side of things, with surgeons, and we sit down and we ask the surgeons to show us, how do you typically do this procedure? What goes wrong, right? What are things that could be better? And then we all sit there together and we brainstorm with that limb in place, ways that we can improve upon those procedures, spaces in which we can innovate around that procedure. So I think the use of cadavers is a very unique and exciting part of the work that we do. And it's absolutely necessary to the success of the projects.
So Tyler, tell me a little bit about how you got to where you are today. What's your background?
Yeah, so I have a little bit of a non-traditional training, I think, for an engineer. It all started, I did my undergrad in a program where there wasn't much definition between the engineering disciplines. And so my undergrad degree is in engineering sciences, and it's the engineering sciences with a bioengineering focus on the mechanical track. So it's but what was nice is that started off sort of the interdisciplinary. It gave me the freedom to make that undergrad degree a little bit more interdisciplinary. And at that time, I started doing research in the lab where I would eventually do my PhD. My PhD was in a very unique program called HST, or Health Sciences and Technology. And it's a joint program between MIT and Harvard Medical School, where you do graduate level engineering coursework at MIT, and also medical school coursework with medical students at the medical school. And it's not, I don't have an MD PhD. I'm not allowed to cut people up. I gained exposure through that to the language and the environment and the culture of kind of the medical world, which I think was very important to continues to be very important to the collaborations that I maintain today and the work that we do today. The other very unique thing about my PhD program is that it had clinical rotations as part of that medical training. So I did 6 weeks as kind of a general medical student type rotating in the hospital, but then I did 6 weeks in orthopedic surgery at the VA, and I was scrubbed in, participating in to the extent that a trainee, a medical student, can participate. But I was holding instruments and holding body parts and helping perform operations as an engineering PhD, which was a very cool and unique opportunity. And I think that very much informed the direction that my research ended up taking. My postdoc was at Michigan, and that was just in more kind of standard mechanical engineering and robotics. And then that led to this position that I'm in now, which is a joint position. I have my primary appointment is in mechanical and aerospace engineering, but I also have an appointment in orthopedic surgery, which helps facilitate those collaborations.
It sounds like it was like a really, really collaborative approach. It sounds like you guys accomplished a lot. Have you had any experiences where it hasn't quite worked out so well and you have failed? I know failure is a really large part about science and research. Have you had any experiences with that as well?
Oh, for sure. Yeah. And I think that the failures serve to make the successes feel more exciting, and we appreciate those because there's so much failure along the way. I think acutely what comes to mind is I spent the first 18 months of my PhD designing a single experiment. We ran that experiment and it was an unmitigated disaster. It just nothing worked the way it was supposed to. And frankly, everything that everybody had said would happen and this would not work happened, and it didn't work. And I remember explicitly actually that, the evening when it became clear, the evening of the day when it became clear that this was not going to work, and that everything that could have gone wrong had gone wrong. Kind of taking a moment and feeling disappointed, living with that, sitting with that failure, right? Sitting with the disappointment, allowing it to settle. And then talking to one of the mentors that was guiding me, and them posing a question of, okay, so what's next? Right? Yeah. Okay. You've moped. Great. It's bad. This did not work well. What did we learn from it? Where do we go from here? And that question came at the right time, because it's hard to hear that question when you're in the middle of the failure.
Yeah.
But it was well posed. It came at the right time, and it led us to a complete reimagination of our scientific process. So I took that, went back to the drawing board, redesigned a new set of experiments, put the big experiment that I'd been designing on hold. We didn't go back to that right away. Went back to a much more fundamental basic science experiment, ran that experiment instead, learned what we needed to from that one, took that back, and then ran the larger experiment again. And that was crucial to the success of that project. So I think that the takeaway from that for me is that I personally feel that it is important not to mute the emotional distress of failure. I don't think we want to become desensitized to it and not feel it. But I also think we want to not feel it so profoundly that we get discouraged, that we allow it to cause us to feel imposter syndrome or other things that to kind of listen to the lies that we don't belong or that we're not good enough, right? I think the best way to engage with failure is to recognize that it sucks, that like it's really hard to be in that moment when failure is happening, but that it is a very normal part of the process, and that what kind of determines how it affects us is our reaction to it, and whether we're going to take it and learn from it or allow it to take over, allow those negative feelings to take over and believe the lies that sort of come with those negative feelings.
So with being an engineer, have you had any like moments that make you really like proud to like be a scientist, or any like favorite moments where you feel like this is what I'm meant to be doing?
Favorite moments. I was fortunate in my PhD work to be able to work very closely with people, with the patients who would eventually be benefiting from the technologies that we were developing. Now as a professor, that's coming, but a lot of my technologies are earlier staged, and we're working on, my students and collaborators and I are working on kind of pushing those into a place where we can test them in people. But as a graduate student, I got to do that firsthand. And absolutely there were moments when things worked, moments when people experienced things for the first time, moments when people shared how meaningful the experiences that the opportunities, the experiences that we were able to provide them, even in just a controlled lab setting, that those were particularly valuable. So one of my favorite ones is, and I think it goes to the unpredictable nature of research and how we often roll with a punch. But one of my favorite of these is we were doing a long trial day. This was, we had done the new amputation surgery that was kind of the focus of my PhD work for the first time. And the person who had this operation, his name is Jim Ewing. He's very open about this, and the procedure is actually named after him, called the Ewing amputation. Jim was in the lab, and we had put a prosthesis on him, a neurally controlled robotic prosthesis. that he was wearing for the first time that day. And I was being very conservative in what we did with that robot because I didn't want it to break.
Right.
And so all day he was asking me if he could stand up with it. And I kept saying, no, we're going to stay sitting. We're going to control it in free space. We're going to get these data before we move on. We take a break at around lunchtime and he's on. And finally I said, okay, you can stand up. I don't want you to put any weight on it. You can stand up. We'll be right there. And so we get to that point. He stands up. And I'm running around messing with wires, doing all the things that one does when running a study. And he stops me and he says, Tyler, check this out. When I lift my leg up, my toes come up. So he lifted his knee, his toes came up. And he asked if we had programmed that in, if that was automatic, and the answer was no, that was not automatic. And that was actually an emergent reflex that was happening in his muscles, we think, due to this surgical procedure, because none of us had seen that in any other person with a traditional amputation that way. So essentially a result that made itself manifest because the person that we were working with decided he wanted to stand up and stood up and convinced me that that was okay. So my advisor Hugh was there, and so he and I looked at each other and recognized what was going on, and he said, what happens if you put your leg out? And so he put his leg out as if he was like going downstairs. He reached his leg out and the toes went down. Because again, his muscles were reflexively firing to make that happen in the way, if you were to, I won't make you stand, but if you were to stand up and put your leg out, extend your leg, your toes sort of naturally reach. And when you bring your knee up, your toes kind of naturally come up. So those behaviors were coming out in the prosthesis. So I ran and grabbed a staircase because it was biomechanics lab. We have staircases lying around. Grab the staircase, put it down, and he comes and we had him walk up and down the stairs and saw immediately this sort of emergent, natural looking going up the stairs, the toes come up and then place themselves appropriately, coming down the stairs, the toes come down. And that was just one of these, again, what I love about this moment is that it doesn't happen if I'm not convinced that he should be able to stand up, right? If the conservative side, the very safe side, which I think as scientists we often are, but if that side wins, we don't discover this, we don't make this breakthrough, or if we do, it comes much, much later. And it ended up shifting the whole course of that study. We ended up designing the study in large part around that particular phenomena. So if there's a takeaway from this, I don't know if you're looking for one, but if there's a takeaway from this, it's that, it's good to be safe and conservative, but you also need to take risks and try things. And you'll often be surprised with the direction the research takes.
With that background with doing scrubbing in and doing kind of medical student work, did you ever want to just say I don't want to do engineering, I want to do medical school?
Yeah, it's a really good question. I hated my med school courses because I really am not a memorizer. I do not like memorizing. And we took our classes pass fail at the med school, and I took immuno twice and was failing it twice, such that I had to drop it both times and eventually did a different class instead. And for those who aren't, immunology is like 3-letter acronym soup. It's just a bunch of these little factors and things and it wasn't entering and staying in the brain. And I ended up doing some of the more quantitative coursework instead. But yeah, I think what I'd say is I would really enjoy, being a surgeon. The problem solving that comes from being a surgeon is fascinating, especially in the if you're in the emergency department or you're a trauma surgeon, and it really is engineering. Somebody comes in and you've got a bunch of things that aren't working, and you have pieces of people that you can take from other parts of their body and reform them and try to recreate the tissues that are missing. And all of that is very exciting. But it's mostly exciting because it tickles the engineering part of my brain, which is the part of my brain that I engage with most often. So I am, and there are parts of it that I don't think I would like as much. One of the surgeons I work with says that I can't remember exactly the language he used, but he called me an engineer who thinks he's a surgeon posing as an engineer or something like that. Which is just I think captures pretty well how I feel about my role, which is that I'm very happy to be an engineer, but be at home kind of in the surgical world as well, and be able to bridge that gap between the two worlds.
Well, thank you so much for being here, and thank you for everyone listening. It was a pleasure to talk to you, and thank you so much for sharing about your research and your life. It was great.
Happy to do that. Thanks for having me.
Thank you. Thank you for listening to this episode of Behind the Beaker. We hope we inspired you to pursue your passion for research and innovation.
Whether that means diving deeper into biomedical engineering, starting a career in academia, or simply exploring how you can contribute to advancing science.
If you want to hear more, be sure to check us out on Spotify, Apple, or wherever you get your podcasts.
We'll see you next time.